Performance testing, load testing, resilience testing. In 2025, having these non-functional testing skills isn't just a nice to have, it's essential. Learning non-functional testing in 2025 is one of the best career moves that you can make. Hi, I'm Rohit Singh, and over the past decade, I have run non-functional testing initiatives at companies like Soprasteria, VMware, and Broadcom. Today, I run my own business, which is called Populosoft, and we specialize in iOS development and quality assurance as a service. If you are a tester, developer, or just someone who wants to build a better software, hit that subscribe button so you don't miss a thing. Alright, let's jump right in.
Welcome everyone to this third lecture in the third module, where we are going to talk about some little things in the test which is related to test design. So this one today is as well going to be concepts. So what we are going to do today is a recap of the design. So in the last lecture we wrote like a small document. I tried to make it a bit formal so we can understand what are the different components that we need to think of when designing a new test. I will talk about one important aspect of building a strong foundation when you are trying to build a solution that's going to work over the years. So some challenges that we face because we begin too quickly and it's not steady enough to build more stuff on top of that. A little bit more insights on test design. Then I will share with you this. I think the last part is going to be more interesting, where I'll talk about one of the projects that I have worked upon. What are the how, like, without disclosing any confidential information, how the solution looks like, the product and the testing solution. What were the missing pieces when I started working on it? So initially, when I began working on that, there were some or quite a few lags that I had to work on. And after some of the efforts, and when we were working on it, what was the value of the efforts, what was gained? So I think the last part is going to be much more interesting. So stay around. So in the last part, we kind of wrote a test in a simple text file of how the test blueprint is looks like in performance. First, begin with the question that we are trying to answer with the test. Always link something to a requirement. Don't start building a test without you have an actual requirement to begin with. So that's my suggestion. Next thing is setup of the system, including hardware and software. So before you run tests, you need to have a solid system. You can't have a really variable and hugely changing system if you want to run the test. So try to set up and finalize a system which is not going to change anytime soon. So you can repeat your test with different builds, different commits, pretty much also repeated for reliability. Then we discussed about a load model. We chose one based on our experience. Finally, we chose a load generating tool. These two steps are kind of linked because not all the load models can be supported by all the tools. So we need to decide it carefully. We decided on a monitoring system. Then there were 3 phases of test. Test designing. So we first sent a request and put some extensive checks there. And then we started scaling the request from 1 to many. So this part is also important to put some extensive checks on each of your requests. Otherwise, it may get messy later on. Test execution is aim for continuous execution and as many runs as possible you via some automation. Also here is not mentioned, but aim for hands-free automation. Last one was we decided on a test reporting methodology. So an easy to reporting sharing system. For example, as I mentioned, there is Elasticsearch. There is I don't know if you. I think you can host lots of such applications. Like Tableau is not an application to host stuff, but maybe they have this feature. But still, you need some kind of a reporting solution which everyone can share. And quickly see the results, so it's not just you. So this was a quick recap of last lecture where we discussed what the test looks like. The next thing is using best practices from day one and its benefits. We talked about lots of best practices, but I wanted to add one more point to this, so I put this slide in this one. We need to build a strong foundation. In my experience, when I worked on different performance testing solutions, more often than not, we ended up in 6 months, 1 year, or 2 years, depending upon how good we were or how much effort we put, having a very complicated solution, which kind of took a lot of time and effort. And then we had to start thinking about some of the basics, like just for example, simple naming convention for the test. We used to have a name for a test, which is the type of test, so it's a benchmark, then the type of load, the files or the server. So we, for example, have 100 KB, then we have the file system that we are using, NFS or something like that. Then we have the number of nodes, 2 node or 1 node test. So kind of like this. But the problem that we face later on is that we started adding databases, and the test name started to grow, and in 6 months time there was not enough, the enough length of the test was not available. Then we started shrinking our test name, so we had to go back and change the old naming conventions. If we had thought about it in the beginning, it would have been much easier. It's just one simple example I tried to explain to you, that try to think about something in a long term, and short term stuff is not, um, yeah, on the long term these things can create problems. So yeah, this picture is from world's tallest building, or maybe the world's, I don't know if it's currently the tallest, but it's from Burj Khalifa. This is the foundation. So you can imagine how much engineering they put in before they can start building the tallest building, because this is the base that's gonna take up the load of the tallest building with so many levels. And it's a very strange and new design with three, kind of based on some of their flower, I think, in their desert, where they, or some plant, which looks like this. So they put concrete, these are like individual concrete cylinders put down below it, and like tons and tons of them before they can even imagine start building it. So yeah, just one point and advice about building the foundation right. Never hesitate to put more effort from the start so you get the right foundation. I think all the product and project managers will understand. Um, Last point about this thing, that you are building test for a changing solution. Another thing that happened to us is a couple of times is that we started off the testing solution when the product was designed to be just like a monolith with some couple of nodes and nothing much like that. And later on we started changing it to smaller services, breaking down each individual process from the big server and putting it onto a separate node into containers and Kubernetes. If we had anticipated this all of the time, then it would have been a little bit easier. Actually, now we try to anticipate it most of the time, but always keep in mind that things can change. So try to put a solution in place which can adapt to such situation. So for example, the monitoring, if you are building it for, choose a tool that can later on support uh, much more number of monitoring servers, and not just a few, because if you choose later on, you will have many smaller services and you will have to monitor all of them. So choose carefully. um, okay, so this is the most interesting part that I wanted to talk about. It's about the one project that I have worked on. It's a classical, it's like a very standard project um, which is deployed on AWS, and it is using EC2 instances for each of its node. They are individual EC2 instances. It uses Chef for automating the deployment of the servers, and then also we use some like Chef recipes are to actually deploy the server as well as some of the components that we need. They also deploy all the server tunings and everything like that. it's it's a multi-cloud, multi-customer environment, which means multiple customers sit in the same environment and they share some of the resources. So our testing solution also needed to be similar, so we could um, test such a thing. So let's take a look. It's time for a diagram. Uh, this is how I created. This is where I created that small diagram just to explain to you how the setup looks like. In this project, we had as I said, multiple customer environments. So first one is here, second one is here. This is the whole system that we test. We spin up different customer environments at different times with some let's say some set of data, which is not which is we don't start from empty, but from some actual customer database. We capture it and then we load it. There is a single load balancer which manages the traffic between different test environments and also between different nodes. So it's a key piece. If this thing gets loaded, which doesn't happen because load balancing is usually not that CPU intensive or something like that process. If it's properly configured, it can handle lots and lots of environments at the same time. Then we had a test executor, and there is like a small automation server we have internal, which sets up the test executor from an EC2 instance, which sets up the nodes. Like it can set up the environment, this one, and the nodes that we need. We started testing with one node and one like a configurator node. And this was the part that was already automated when I started working on it, but there were some big problems with the solution. The first problem was that you can spin up this automatically, you can spin up this automatically, you can run the test, but for monitoring and for result analysis, there were key pieces missing. Monitoring was not there so much. Nobody knew what's going on node 1, node 2, and node 3, like in terms of the utilization of resources. So what we did is to start adding a monitoring solution. The red pieces were missing and were added later on. So we used Elasticsearch to as a central repository to save everything from different nodes, and we used Elasticsearch as a monitoring system as well. So yeah, this Elasticsearch can store tons of different data. It can store monitoring data, as well as it can analyze and visualize and graphs from the logs. So pretty much we put this piece in here and we hooked it up to all the nodes. So we started viewing more information. We did not have any automation server. This thing is actually still in progress, where we um, um, automatically run this test by spinning up the test executor. So what started happening after we put in more efforts, we also had to analyze some problems, because the common load balancer sometimes was actually causing us problems, because when we ran more than 3 or 4 test environments, we were not sure. We had some ups and downs in the performance numbers. So we started analyzing if the load balancer could be causing some kind of problems. Um, we decided not to use more than 1 or 2 test environment at the same time for the best numbers later on. Also, we put in a warm-up time. So this was the analysis that we did for this test. And because the test was run ad hoc, it was not fully automated. What happens is that it runs every time you try to spawn a new. It runs when you run it, basically. So you have to get a new build and you have to upload it to the our automation server, which that step was not automated. So you have to go down in the morning, upload it, and then run the test. After few hours you will have the result, but then you have to manually download the results and analyze through them through simple scripts like SSH and Perl scripts. which every time we ran a test, it was a lot of work. So what we did is, as I mentioned, here we now it's completely automated. We don't have to go and do anything like that. We did some analysis to improve the test. We put an automation server, and we started seeing some value. So um, this is the missing pieces that I was talking about. Um, there was no continuous execution, that the results were not repeatable. And I'm talking about this because I have worked on several performance projects, and people get started on performance projects, but the big problem that they face quite a lot of times is these missing pieces. They don't get full value out of their solutions because of these small things. Small things matter. Um, Reusability of the baselines. What I mean by that is, when you run a test, you have to store the baseline, which is like the previous uh, correct or the previous okay build of the test, and you have to save the numbers so that you can compare them with the new build. But what happens in some of the test environments is that every time we run a new test, we can't clearly repeat everything that we did the last time, because the data set has changed, the set of data or the set of configuration tunings has changed, and you have to run pretty much two tests for the same value that you can get with one test if you have repeatability. If you have one baseline always ready, and you want to run only the test, then with the repeatability you can it will save like half the time all the time, plus you will have a historical visibility, like how much was the performance with the last build and how much is with the current build. um, it was missing a monitoring solution, which is a really key piece, and this happened like couple of times with my projects when I started working on them. There were some already existing tests, but the monitoring was not enough to actually find issues. It was not hands-free, that I probably mentioned in some of the previous lectures. Several steps were manual in between, which led to not an efficient utilization of resources. Also, for example, if you have to go and download the logs manually, it is a wastage of resources. If you have like 8 EC2 instances in AWS, and after the test, you have to manually go and download all the logs from the servers, you probably will have to keep it running whole night and then come in the morning to download the logs, which is going to bill you even more. It's If you start a test around 4 p.m., it's definitely going to run until, or if you set off test, then it can run all night, or maybe finishes at the midnight, and then you have to come and download in the morning. It's really killer of productivity. So this is what we are aiming for. Most of the pieces are now automated. One or two are remaining, which will be done. The last one is, yeah, this has been the story, which is why I wanted to mention it. So whenever you get a chance to work on a performance testing project, you might have to do an analysis of the missing pieces, and I'm like pretty sure that some of these will be missing if it's not properly implemented. And if you can bring all of these capabilities, then it's gonna benefit you really quickly and really well. So after we started putting in more effort, we started uncovering some of the defects and issues which were pretty much not visible before that. Um, so because we now had a better monitoring of all the logs in the system, which is not just a single log, but we actually got all the logs and imported them. So we started seeing new exceptions with some new commits, and we already had some existing exceptions that we couldn't match to any of the older any of the older issues. But then we just noted them down that these are the existing ones, and if we get any new exception error in the logs or new warnings as well, then we are going to report them and we are going to analyze and debug them. We started detecting exceptions, and interesting part was that with each exception we were able to also, because we had the monitoring of the queries as well, so we started monitoring, we were able to match them with failing and missing queries. So each exception was equal to one failed query, and it led to several times, like 2 or 3 times, we had hot fixes done on the project. So immediately the team decided to fix the issues because some of the exceptions and some of the failed queries are not acceptable. So we immediately fixed it, did a retest, and when it comes to retesting, you need, as I said, repeatability. So we repeated the same test again really quickly, and we were able to minimize the effort and as well as gain a lot of value. Then the second really interesting part that happened, because now we had system monitoring data um, available from all the hosts, we started noticing two things. First one is that when we had like change of in our systems, we change the input data, like new set of data arrives every day. This is like an update of the product catalogs, things like that. And whenever we did an update of the product catalog, the capability of the system to serve new queries drops down like hugely. It drops down to half, and we uncovered this problem because we could see some spikes on the system level, which is the CPU and the RAM, when we were doing such updates of the product catalog data. And at the same time, whatever queries come to the system, they were hugely slow. We reported this, and it's since then it has become a huge investigation. Actually, the developers had some, let's say, um, speculations that it might be happening, but they were never sure, and now they are sure, and now they actually have several stories to fix this kind of a behavior. If we manage to fix this, this will bring down our AWS costs by quite a lot, because lots of our uh, deployments have uh, tens or 20 or 50 servers deployed all the time, and it's mainly because of this huge, let's say, consumptions. And if they can actually fix this problem, which we'll try to help them with, then these costs will come down quite a lot, as well as we will be sure that we can meet SLAs any point of the day, not just when. So whenever the product catalog is being updated, we can still meet the SLA. The last really interesting thing that happened, that because now we have a historical view, we were several times able to catch performance degradations between a new commit and a really older one commit. And we can now tell the developers that, okay, between this version and this version, between this date and this date, there were some changes in the performance, and these queries were impacted. This is the average query for this is the average time for this query, and you need to start debugging. So several times we were able, like, it's hasn't been a really long project, it's been actually a short project, and we already several times pointed out to the developers, and they started reverting and improving their fixes immediately. So yeah, pretty interesting project, this one, and pretty interesting findings that led to some really valuable outcomes. And I wanted to show you, just to give you a feel of what kind of work you can expect when you start working on such. So there will be two types of projects that you can possibly get. One is from the scratch, where you're gonna need to implement lots of concepts and to actually tell everybody else that this is how the performance testing is done. These are the gains from it. These are the tests available. What would you like me to build? These are the best practices that I will put in. The second type will be where you already have a solution, but you need to improve it and to start using it to find more issues. This is when you have to do this key piece analysis, where you have to find the missing pieces and start fixing them. And I think I just wanted to give you my opinion about which are the most important missing pieces when you look at a solution. And I hope it will help. That's it. Thank you so much for joining, and have a lovely rest of the day.